Hi guys, today we'll be talking about correlation regression details. Okay, so last time we talked about residuals and lines of best fit and everything. Alright, but today we'll be talking about the actual stuff. So what they're actually talking about is just looking at outliers and then looking at the R squared. Okay, the regression, the R squared just basically. Okay, so first off we actually have, let's go blue. Okay, our line of best fit goes through here. Now, normally, if the data is pretty packed around there and it has a strong correlation, here's the thing. If I have an outlier up here, it might move my actual line up a little bit. It just kind of influences it a little bit, have it off track. However, and this is on the Y scale, okay? So the Y scale, here's the X coordinate, the explanatory. Alright, if I have my outlier down here, it could actually change the entire direction of the LSRL if I have it really skewed. Now, obviously it's not going to be that bad. It actually has to be out here for that to happen. But outliers are something that drastically affect everything. So you want to plot the points, look for obvious outliers, keep that in mind when you're doing the residual plot, and then when you're graphing your, not your residual plot, when you're plotting your data, and then when you're plotting your LSRLs, on top of that, you want to keep in mind what outliers could be affecting it. And you want to work with those and just see which ones you could get rid of and just go, okay, which ones do I not need? You know, something as simple as that. Just remember your R squareds explain the percentage of the data that you have to use the context. If you're just saying, oh, you know, my R squared, let's say your R squared was 95%, something simple. You would say, oh, 95% of the time, Y explained X. That doesn't give any kind of context. You want to give some context to it, and you don't want to say 95% of the time. You want to actually say 95% probability. Hold on, let me get the exact wording details. I wrote it down. I always forget it. It's the percent of the variation that it explains. So, in other words, 95% of the variation of the data is explained. Okay, if you use this context, you can actually make sense of what R squared is. And R squared actually helps you with the actual variation. So the tighter the fit around the LSRL, the higher this number is going to be to 100. Okay, and also conversely, you can say 90 or 5% of the variation of the data is not explained, and that explains what these outliers are doing out here. So that's the explanation behind the correlation and regression details. Remember, your regression line explains a predicted model. Your correlation explains a relationship between the two. And remember, causation does not mean correlation, or correlation does not mean causation. And on top of that, residuals do not explain everything. They actually tell you if your line is a line of best fit. It'll make a random data pattern, which is actually kind of interesting how it works. Alright, that's it for correlation and regression details. I'll talk to you guys later. Good luck on the test.